All right, class, welcome to Friday. We last time on Wednesday, we finally got to example number 1, is that right? And we did this guy. We did something we know already. Y is equal to x squared. But we did it in a, almost, you can say almost complicated way, right? I mean, we use this formula. We know what y is equal to x squared. We've been graphing those since algebra 1. So let me kind of put a few little ideas in your head here. So this is like the overarching, most general way of doing parabolas. We're good. So it's almost like this. When we do y is equal to x squared, we did not know in algebra 1 that we had all this stuff sitting there. We did not know that there was a directrix. We did not know that there was a focus right over here, right? All these different things are now being sort of added on to what we thought we already like, oh, it's just y equals x squared, that's it. And so it's kind of like this here. This is maybe a good. Okay, you guys talk to me here. You guys know this already here. So if I were to write down a 3, like, let's see, when's the first time you guys were ever written down a 3 in your life? When was that?
Honestly, first grade.
First grade, probably, if anything, right? 3.
I didn't use the number 3 until about 8th grade.
8th grade. So wrote down the 3. Can you guys tell me? When you guys were first grade or when did Luke write down the 3? Or 8th grade? Did you guys know? Most likely first grade though. Is there an exponent to this 3?
Yes.
Oh yeah, where is it at?
It's right about there.
It's 1. It's
Okay.
zero, but it's there.
That's weird. So in first grade, we did not know that was there. Is that right? Never got it. Like, what are you talking about that? Okay. Could this be written as a whole piece of a fraction? Yeah, we can always write numbers as over 1, right? So you have all these different pieces here. Oh, interestingly enough, is this 3 also a part of a complex number system? Whoa, craziness. Okay, so you guys ready for this? So 3 is a real number, but all numbers are complex numbers, which means they have an I next to it. Yeah. But because 3 is just a 3, doesn't have the extra piece to it, what we do is we just say this guy has a 0 next to it. We're good? That's how we write down a 3. So guys, at this point, that's what a 3 is. We just never, right? But so as you guys were graphing this stuff, right? Like what? But that stuff really is this stuff. Okay, that's what this stuff really is. We good? There's your sort of most general, this is it. So we can move these around. We have a p-value. There is a focus. There's a directrix to these parabolas that we kind of did not think about good before. Okay, so example 2, let's jam. Ding, 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 ding. And we're gonna find okay, yeah. So let's graph this graph and find, you can do it vice versa. You can find the equation and graph it. Graph and find the standard equation. Of a parabola. Lots of writing here, guys, because I'm trying to put in words so we can then write down the formula here.
I think to give us more time, we should make the homework due Wednesday.
It already is.
Wow, I'm one step ahead of you, Noah.
I thought it was due Monday.
No, it's due Wednesday.
The test correction.
Oh.
No.
Sorry.
No problem. No problem. I'd rather have a conversation in class and stuff. Yeah. Okay, guys, all yours. Go.
What's
Yes.
vertex again?
Say again.
What's a vertex again?
Vertex. Oh, vertex is when the graph shifts from like going down to going up, or going left to go right, or from going left to go or left to right, and left, right to left. It changes direction. So we have a parabola with the equation with a vertex at the origin. So let's do this real quickly here. So I got 4 different possibilities. 1, 2, 3, 4. You guys tell me which one of those is the correct one. So I have a graph that could be going like this. I got a graph that could be going down. We've seen those in algebra 1, algebra 2. And now we have the general form that can go to the left, and it also can go to the right. Awesome. Screw the line.
It's
Done.
the one going, it's the one going that way, right? Because the focus is 2, 0.
Oh, awesome. Okay. 1, 2, 3, or 4.
3. Well, look at the focus. The focus is 2, 0. It has to be inside the travel, so it's-
Yeah, because that little focus at 2, 0, you know, it's right there. So it has to be 3. We're good. Hey, cool. We kind of sort of graphed it. That's cool. So the correct graph looks like this. Absolutely. Comes in like this and goes out. That's the vertex. There's a focus. That's where the antenna beam would be, or direct TV.
I mean, I've learned that you can actually use the satellite dish. If you put your phone at the focal point, you can actually get a higher frequency, or like higher if the bars on your phone is like 1.
Mhm.
I've used it to get 5 bars before.
Oh, how cool. Interesting.
So if you really need internet somewhere, you can just bring one of those with you.
Uh-huh. Okay, let's see, which formula here? Horizontal axis, yes. So we have this little formula. You guys talk to me. What do you think what is? Just tell me. I think I have it like this. The only thing is P cannot be equal to 0. That's it. All right. All yours.
Oh,
Mhm.
What do these variables mean?
Ah,
We haven't really explained.
let's
that.
go with it here. So X, notice that the Y minus K, it's just a subtraction piece. So this is your horizontal movement or vertical movement. And I think we probably should know what this guy is. Cool. And the p-value, what is the p-value? Yeah, because H does go with H, right, for horizontal. V, the only problem with V is it is a variable if you go into the 4th dimension. It's a common variable. So
Wow.
Yeah.
yeah, just whenever you go in the 4th dimension, you just need it. And
pictures of like what the 4th dimension would look like if it came into contact with the 3rd dimension. And it's just weird. It's mind-bending.
So I'm going to let vertex is at 0, 0. So there's no movement away from the origin. We're good. I got this guy, K is equal to 0 here. H is equal to 0. Now we just need to find P. And so we do have a formula that connects X, H, and P. It's like this right here.
Yeah.
Let's go. I'm gonna find out what P is. I wonder if it says it in the book. Okay, just making sure that it says it. And P is the length from the vertex to the focus. So here's your P value. Again? 2, So K is equal to 0, H is equal to 0. We have 4 always is there. So I think I'm ready to put this in.
Directrix to focus or origin to focus? For the length.
What a beautiful noise, definitely not.
I mean, that just looks like it's like, we don't even know where the directrix is yet, so is that the length from like focus to the origin or the focus to the directrix?
Oh.
This is the Directrix formula.
What's the director?
We'll get there. We'll get there all.
Okay, so P is the length from the focus to the directrix?
P is the length from the vertex to to the focus.
Yes, okay. Do we know why?
See again?
We don't know why.
Y is a variable, so we're not going to put in. That's the variable that we want to have. So it looks like y minus 0 squared.
So we use two formulas this one time in directrix. We use y equals k minus b and x equals k minus h minus b. Can I just assume that the x1 is flowing sideways and the y1 is flowing upright? Please. Listen, I'm just trying to define everything because we didn't know what any of these meant was, but.
Sure. Have you ask again, just real quick, just to make sure. Let me just
Oh.
put
Never
this
mind,
together.
I see it here now. I was just saying that the x equals h minus p, that was like horizontal axis. So the other one's
Axis.
the vertical axis.
Yes, yeah, it just depends on. So the axis here is a horizontal axis. So you're going to use the second equation I gave you guys.
Right.
Maybe you could explain that to me, I'm sorry.
Sure. Yeah, let's go back to what we did on last time. So this guy, notice where the axis is. This is a x-axis. It's a horizontal. Good. So if that's the case, and we go back to our formulas here. Oh, I did mention it right over here. So this guy is for the vertical axis. That means this guy's either going up or down. For the horizontal axis, we're going to get this right here. And essentially, if you guys kind of just the easy one, this turns out to be y is equal to like x squared. We're good. So that's something we've already graphed before. It could either be positive or it could be negative.
Okay.
So, but notice that the axis that divides the parabola in half is a vertical axis.
Okay.
On this one, the horizontal axis, there it is. So this one essentially is going to give you a y squared defined in terms of x.
Also, does the focal point only work up until you get past a certain point?
No, it should work all the time. Depends how big the
Because if
dish
you
is.
Point it directly at the thing, then wouldn't the light come directly back to you? Not like.
And like that's the only, like in real life pieces here, you do have an object that's sitting here, right? So a direct TV antenna, right?
Yeah.
So you do also have on a direct TV antenna, you do also have a like a little piece like this that connects. It's like a side dish. It's connected on that side, right? So obviously the TV waves, right? When they hit that, they're not going to hit into the antenna piece, right?
Yeah.
They're just banking on all these guys here. And then the other one is, well, let's see, one of the factoid of DirecTV is they always point towards Dallas, Texas. That is the craziest thing.
Why?
Aliens. Absolutely.
Is there a reason?
Yeah, because the satellite for DirecTV always circles above Dallas, Texas.
Oh,
Its rotational axis is above Dallas, Texas. So they just point generally towards that direction. And I'm not sure, that's when it was, that's years ago when they were setting it up in our house. I assume maybe they got like, 2 more or 3 more antennas, but you just need, as long as you maybe have 3 antennas, you're gonna cover the whole United States, right? Pointing to which direction. But when they were setting up at our house, I was like, why are you pointing it that way? Because I always point towards Dallas, Texas. Okay. Okay, are we good with this one? We got the answer. Y squared is equal to 8x. A question?
So I did the vertical axis, the same one with all axis formulas. And I don't think they got it right, but it's like, is it just zero, y equals 0 minus 2 for the like vertical one? It's whatever, it's equal to 0. What is that? Or am I being that wrong?
Oh, I think you're talking about the directrix, right? So let's do this. Let me do this equation. Let's see what you have. So we have to graph the directrix right here. X is equal to h minus p. H for us is 0. And p is 2, because it's the length here to here.
He's supposed to be.
It's not.
So x is equal
So you mean like that
to,
now?
so x is equal to -2. Can you graph a line? X equals -2, that's a vertical line, isn't it? Yeah, that's a vertical line. So we go 1, 2 back. We've got a little busy on the slide here, but let me do this in red. So here's our directrix line right here. Coming all the way down, goes like that and like that. On the directrix line, they don't ever put arrows. They just have where the point is.
what's a directrix line? What does it do?
Yeah,
Why is it there?
I don't,
just need to
I'm,
know.
I'll have to find out if there's actual applications to it in real life. But in mathematics, it's this right here. It's the fact that from here to here, if you went straight up, this would have the same exact distance as this right here.
Oh, right.
So the distance is exactly the same.
Okay.
And I'm not sure if it's a, let's see, because usually when the antenna comes in, that's the receiver, right? So I'm not sure if there's a real life application to directrix. Right? Just a math. Okay, we good. Let's see, let's go a little bit more complicated. Example 2 or example 3? Example 3. Okay, so I'm gonna find the standard form. Can I just do this here? I'm gonna give you guys find.
What should the horizontal axis have been there?
Let me write this. Let me write this up now, and then I'll help you out here. Let's see. I'm gonna give you guys 2 minutes to get started here. Here's what I got. The vertex is at 2, 1, and the focus is at 2, 4. So all yours, trying to figure that out. Give you guys a couple of minutes here. Let's go. All right, just a quick little graph of this guy here. So the vertex. So I guess we can just do it from the vertex and the focus here. Let's see. 1, 2, 3, 4. One, 2, 1. So here's my vertex. And then just based upon where I know my focus is at, everybody okay there? I know this guy has to come in like this. Everybody okay there? Cool. So that means I flip to my equation here, and I say, okay, that's going to be the vertical axes. So I go with x minus h squared is equal to 4p y minus k. And then my directrix, let's just put d for directrix here. My d equation is y this time. Y is equal to k minus p. So I'm going to figure out what that little directrix is. Awesome. There it is. H minus 2. The movement horizontal. That's the movement vertically.
And then would PB3. Distance from that focus to the vertex.
Yeah, what is this guy here? 3, everybody? Tell me if you guys agree. Okay, I agree.
But what do we do with that then? Are we multiplying the x minus 2 out, or it's where it stopped? I don't know how.
Yeah, so let's see. This one in standard form, that is it right here. As long as you put it in, maybe just multiply the 3 and the 4 together. That's standard form right there.
Oh,
Doesn't look. I mean, you could put it into quadratic form, right? You can multiply everything back out, but that's it right there. So now we'll just go for the directrix. Let's do it by formula. And let's do it the easy way. Formula is y is equal to, k value is 1 minus 3, what is that, negative 2? Y equals negative 2 is the formula for the directrix. It's going to be horizontal. Yeah, it's horizontal because it's y. True, true. And then let's graph it. I'll graph it red. So, okay. I'm waiting. I'm waiting for someone to show me, like, Mr. Hengiev, that's so long to do. I can figure out the directrix just based upon the graph itself. Awesome. Yeah, so if you're going up 3, all we're going to do, we're just going to go down 3. And we're good to go, right? Because there's our graph, and then we just make it a horizontal line across. That is it. Oh, the fun part is, but when we start rotating these conic sections, then it kind of helps to have an equation that gives the directrix. Rotating them, like rotating them 25 degrees, rotating them 30 degrees, 60 degrees. Anyways, we're in there. Okay, with that, we have finished 10.2 and we're done. Have a good weekend. And I'll see you guys with test corrections on Monday.